This is Astronomy Daily Live for the 19th of May, 2018. Hey, everybody. Hope everyone's doing well. Come on in. Come on in. Join the circle of friends in this virtual porch, this virtual lounge where we gather our comfortable chairs and our choice of drink or other consumable and come in and talk astronomy for an hour or so. So hope everybody's doing well. Hope the past 23 hours was relatively okay for you. I'm gonna pull over the chat. I'm gonna get my live stream running on my smartphone. Thusly, go to there, and then go to there. All right. All right. Looks like I am live. Cheers. Welcome to those who are watching this live. It is 2:01 UTC. It's about to turn to 2:02, I think. Now, I'm located in southeastern Arizona in the United States. So I'm actually on Mountain Standard Time, and Arizona is one of those few, I think, locations in the world. Hey there, Tom. Nice to see you in the chat. So Arizona is one of those few locations, I believe, in the world that uh, does not participate in daylight savings time. So I am always on Mountain Standard Time, which this time of year uh, puts me actually in the Pacific Daylight time zone. Whatever. I mean, everybody has sort of a beef with daylight savings time and whether to have it or not. And most people think that it's dumb, and you should just um, um, get rid of it, right? But I'm here to tell you that those kinds of things are completely arbitrary. I mean, look, language, the sounds that we make, right, is arbitrary as well. It's just the, I mean, and that goes with everything, right? Um, the the only thing that's really required is that most of us um, uh, all agree to these choices. So really, it doesn't really matter if you adhere to daylight savings time or not, because actually the fact of the matter is that there is one time, and that's right now, and there is no other uh, you know actual time. It's just right here and right now, and that's about it. Everything else is sort of made up, sort of arbitrary. Um, so, yeah, I only mentioned that I'm on Mountain Standard Time because, well, that's what I'm on, and Mountain Standard Time is 7 hours behind Coordinated Universal Time (UTC). And so while it's 2:04 UTC on May 19th, 2018, I, and in fact, I've still, oh yeah, I've got a little bit of sunlight left. Um, yeah, the sun is just setting now. Um, I am 7 hours behind that. So I'm actually at 7:04. It's about to turn 7:05 p.m. Mountain Standard Time. So, yeah, well, welcome everybody. Let's see, Bobby is in the house. Gilles is in the house. Yeah, hope everything is well. Hey, I saw your Gilles. I saw your well, I watched um, uh, your random live stream last night, and yeah, I think um, you know I I think there's this live stream wave that is coming on, and it's been coming on for a while, um, but this idea of what I'm doing, having a daily thing. I think that's definitely. I don't know if it's a rising wave or if it's just a wave, but it's a wave, and I think a lot of it right now um, is popular because it's sort of novel. It's sort of a novelty. But the funny thing is, and I'm uh, I'm starting to see kind of interesting parallels between this kind of live thing and live television broadcasts back, in the 40s and the 50s, right, and the 30s, right, when they didn't have any means of really recording, right? They just had to broadcast, right? I mean, they had a tower, uh, with 1.21 gigawatts, and they just had to. I mean, th- that it was precisely, precisely was live streaming, right? I mean that is the only difference, right? The only difference between what, well, I guess there's two, right? And yeah, there's one primary difference, and that is that most live streamers don't have like this big, production team. At least not the ones that I've seen. Maybe the extremely popular ones, do have a team. Um, but I think for the most part, um, uh, um, you know, there isn't, you know, like a director, and there isn't a cameraman, and there isn't this, and there isn't that. It's just sort of one person. And what I was going to say was the second difference is that is that um, is that they were broadcasting over radio waves, while we sort of broadcast over wires. But once I thought of that, it's like, well, this laptop right here is connected to you via Wi-Fi to my router, right? Which is then a wire uh, to my um, um, ISP, and from there, I'm not quite sure how they're tied in. It's probably a physical thing, but so at least a little tiny bit of this does go back to radio as well. So, uh, but yeah, and as Gilles um, 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 points out in the chat, that one of the other differences is that uh, back then, right, it was those that uh, well, okay, see, I'm going to change my mind on this too. What I was going to say is that the ones that could broadcast were the ones that had the equipment to do so. And Gilles, I mean, I don't think that anyone can be live, because you need the basic equipment, right? And I think for the most part, correct me if I'm wrong, but I would say that the majority of the population of this planet do not have the equipment. So not everybody can be. You still have to have sort of the means to do it. Now those means have changed, right? You don't need a 1.21 gigawatt um, uh, um, tower to broadcast, to the world, right? Um, but you do need, some pretty sophisticated equipment that has, sort of evolved into this relatively easy thing to use. So yeah. Um, uh, yeah. Well, I totally agree. I think I, you know, I'm going to agree with you there, Gilles, because yeah, I mean, um, back then for unknown reasons, haven't really looked into it, right? It was sort of decided that there would be three networks, right? Three different channels, right? Which do go back to um, radio frequencies, of course. Um, but yeah, for some reason, it was decided either, it might be some kind of technical thing. I'm thinking more it's probably a political thing, where it was just sort of decided that we shall have three privately owned, government licensed television channels, and then I don't know when PBS came on board. I want to say that was probably maybe in the 60s, maybe the 70s. I'm not sure. Cheers. Gilles points out another interesting difference, right? The live streamers of the past had no real way of connecting with the audience that they were um, talking to, right? They have absolutely no way of doing that, and we of course do anywhere on the planet. I mean, Gilles and I are thousands and thousands of miles apart, right? I mean, long ways away. Yet here we are having a conversation, right? So yeah, absolutely. That's another big difference. What other whatever um oh, okay. So at least according to Tom, as of June 2017, 51% of the world's population has internet access. Okay. All right. Um yeah, I I could accept that for sure. Tom, if you have a way of finding like a reference to that, I would like to see a little bit more. Uh, yeah, but that's very very cool. And actually, sorry, the uh, the talking about the direct um, connection. That wasn't Jill. That was Uncle Bill. Uncle Bill. Yeah, absolutely. Uh, yeah, yeah. Well, that's why I say, anybody that has the means to do it can, right? And apparently that's becoming a larger and larger number. Now, I mean, internet access doesn't necessarily mean internet user, right? I don't think. Um, but yeah, that's pretty amazing because that's 51% of the planet. Aren't we over 7 billion now? Something like that. So let's just assume that's 3.5 billion people. That's 10. That's 10 times the population of the United States has internet access. So yeah, yeah. Anyway, so I just thought that there were, though, some interesting parallels, um, in that uh, this is how television started, right? Television started with live streaming, right? Um, and YouTube, for the most part, I mean, I I've known about and have been on YouTube since it started, right? Um, I think I early on I had another YouTube channel. I don't even remember what it was called, um, and um, actually, YouTube back then, as far as the videos and go, pretty much exactly the same. It's just some people, talking about things, and they post it up, and that's it. So yeah, YouTube has changed in other ways, right? With all the advertising and the revenues and all that kind of stuff. Um, at first, YouTube was just a a way for you to be on the tube, right? So yeah, yeah, 7.6 billion. Yeah, right now there's 7.6 billion right now. um, uh, One of my favorite. Yeah, is that um, is that the lady that's doing the sand art? Yeah, I'll bet you it probably is. I'll bet you it probably is. Yeah, very very cool. So yeah, as I said, I'm just seeing some interesting parallels there. Between sort of early TV live streaming and the live streaming of today, and yeah, well, let's see how it evolves. Yeah, sand experiment. There's a I you know I've only caught her thing a couple of times, and so I'm gonna have to check her out again a little bit more over on Twitch. If you go to Sand Experiment, um, yeah, she's pretty amazing. She's pretty amazing. So okay, all right. So 4.1 billion internet users. Wow, wow. Um, cool. Thanks, Tom. Thanks, Tom. Um, so yeah, yeah, just an interesting parallel. So let's talk a little astronomy. I've got. I don't know if I think I've done a little bit of show and tell uh, with this before, but I wanted to bring it up again because I watched um, Alan Stern and David Grinspoon give a talk at Griffith Observatory, probably in the past week or so, um, when they gave it, and I think I watched it. I watched it this morning or yesterday. I forget, and they're talking all about Pluto and New Horizons and all that. So cheers. That's a that's kind of an interesting and strange habit, um, Uncle Bill. I'm gonna have to think about that a little bit. That's an interesting habit. Yeah. Anyway, so I was thinking about Pluto, and so I wanted to do some more show and tell, and I think there's something in here that I didn't show you before because I'd forgotten about it um, until uh, uh, I looked at it again today, and it's like, oh yeah, yeah, yeah. So this this, as far as I'm concerned, is sort of the definitive story on the discovery of Pluto, and of course written by the man himself, Clyde W. Tombough. So it's called Out of the Darkness: The Planet Pluto, and it's actually, you know, a pretty small book, but it's pretty fine print, right? That looks pretty small print. So yeah, the show and tell that I wanted to do was a couple of things related to Clyde Tombough. Um, the first, I guess, is I'll show this. So on March 28th, 1988, Monday, March 28th, 1988, at 7:30 p.m. for the admission price of $5. $5 uh, at the Flandreau Planetarium Star Theater, it says on here, which is on the campus of the University of Arizona. I got to see the man himself. I got to see the man himself. He was, he would have been 80 years old then. Pretty sure. Hold on. Okay, so he was born on the 4th of February 1906. So in 1988 he would have been 82 years old. He was 82 um, when he came and gave a talk, right? On, guess what? Guess what? Um, so that was pretty cool. That was pretty cool to actually see him, be in his presence. I'll tell you the rest of the story afterwards. Um, I, I, I do need to mention the lecture that he gave because uh, what it sounded like to me was a guy who was really, 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 really tired of telling this story. He he told it with absolutely no enthusiasm, no emphasis, no nothing. I mean, he told it so many times that he had this thing memorized, right? So he was basically reading a transcript in his head out loud, right? So that that was that was really sort of the only, I mean, if I can say, you know, disappointing part uh, was that you know, it was really obvious that he's like, okay, I I know that I should do this, and so I'm doing it, but that's all, and I'm really tired of it. But that's all that anybody wants to talk to me about. So there's nothing I can do about it. So, you know, so yeah, it was sort of a canned presentation. I don't really remember m- much about the presentation itself. I know that it took place, you know, in the planetarium itself. So must have had some kind of graphic, some kind of, you know, projected view of something, but I honestly do not remember that at all. So, cheers. So that that was very, very cool. Now, 3 years. Is it 3 years? Let me look here. I'm going to cheat. Yeah, 3 years beforehand. 3 years before that, I had uh, written a sort of a paper slash report for a contest that was going on, given uh, um, given by the Astronomical League, and it was some kind of young astronomers. I think it was some kind of scholarship thing. They were going to give the winner like $5,000 or something like that. To put towards some kind of college or university education, right? And so I thought that was pretty cool, and so at at the time I was really into observing, right? I mean, I had my 10-inch Newtonian scope on a Dobsonian mount, unguided. It was just a looking telescope, as I say, and um, and so I was pretty heavy into just the observing. As I said, when I did um, Messier marathons, I did Messier marathons plus. So I do uh, I I'd be able to do an entire sky of Messier objects in 2 hours or so, and then I'd have to wait. Right, I'd have to wait 2 or 3 hours um, to sort of get the next sky. And so in the meantime, uh, I would observe um, as many um, NGC objects as I could. And so, yeah, I mean, I was heavy into observing, making notes. I think I did a little bit of drawing, but it was mainly notes. What I did is I took um, William Herschel's uh, um, uh, means of describing non-stellar objects, and I sort of adopted that uh, as the way that I was going to describe the objects I was observing, and so um, had had a notebook, and yeah, so heavy into observing, and so the paper slash report that I wrote was on that, how to observe different kinds of objects and what those observations, would entail, right? And so I, sent this in, right? Um, and uh, didn't hear a thing, right? Didn't hear a thing at all. No word on whether they got it. Um, no word on who the winner was. Um, Nothing, right? Nothing at all. Um, and this went on for months and months and months, as I recall. Um, and um, I don't remember how this went down. I got the letter here. Let me look at this letter. See, I got a letter. I got a letter from the Astronomical League. See when it's dated? 16 of November 1985. So let's just let me see if I can read this. Uh, okay. All right. Yeah. That's what it was. The results were supposed to be mailed to everyone, right? And that's how it was going to be announced at the Riverside Star Party, and then from there, word I guess was supposed to get out, and that word never reached me. It never reached me. So So, phew, that was hard. So, you know, I got a hold of him, and it's like, hey, what's up? What's, haven't heard from you, haven't heard the results, should have heard the results by now, blah, 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 right? And so they sent me a package. They sent me a package, and part of it was this letter, right? And the other was this book, this book, right? Out of the darkness. Oh, here, there's a thing on here. Now, as you can see, the sleeve of this book is missing. And that's because when I get a book with a sleeve, the first thing I do is I take the sleeve off because it's just going to get all messed up anyway. So I will take the sleeve off, and if I want to keep it, if I want to hold on to it, then I'll put it in a safe place, right? Otherwise, it's just gone, right? So most of the sleeves, most of the books that I have here, rare occasion, I guess. I'm looking at the books on my shelves above you there. Most of these are, I've got a few with sleeves still, I guess, but no, not too many, not too many. And those are all torn up, right? Anyway, so I got this book and that letter, and I thought that was pretty cool. But then I opened it, and I saw that. So you can see, with best wishes, Clyde W. Tombough. And I think it says 19 July 1985. And Patrick Moore, too. I didn't care about Patrick Moore. I thought that was awesome. I thought that was extremely awesome. They never told me exactly how, where the letter doesn't say anything about where I was in the standings, right? So I have absolutely no idea. But the fact that they sent me this was either because they felt really bad about me not hearing, what the results were, or it was impressive enough to sort of, get them to do that. Anyway, so at that lecture on the 28th of March, 1988, I actually, afterwards, he was kind enough, to stay around and meet people and sign things, right? And so I got to shake his hand, right, and thank him, and I forget exactly what I said, but I had this book, right? I had this book, and so I showed him where he had signed it 3 years prior, right? And I asked him if he'd be able to sign it again, right? And he did. So I've got Clyde Tombough's signature twice. Who's got that? So yeah, I think that's very, very cool. Now, the thing that I forgot about, and this is going to be kind of hard to do with one hand, but I'm gonna try to do it anyway. Oh, I lost my. I was using the letter as a as a as a bookmark, but I can. So yeah, this book is about his discovery. A background. Um, why they thought that there was a planet X out there by looking at the orbits of Neptune and Uranus, and maybe sort of having an idea about where it might be, et cetera, et cetera, et cetera, right? So anyway, so that's what this book is all about, is the history of trying to find Planet X, and also, of course, his involvement in that. And the part that I forgot, as I said, I think I showed you those signatures in a previous live stream. I don't know, um, a while ago. But what I forgot to mention was that in the book itself, on what is this? This is chapter 11. It's called the ninth planet discovered. Right? There are markings in the book, little arrows. See up here? Look at underlining arrows. There's more. So these are actually the discovery images, which he marked. He marked them north and east, and see the little arrow there? It's pointing to a little dot. And if you look over on this side, well, where is it? I guess that's it there. Yeah. There it is again. So, and again, he marked it north and east. And look, he's written in my book. What did he write here? Okay, so what he's doing is can you see that big bright star there? That thing that looks like a ring, right? That's an overexposed, very, very bright star. And so he wrote in here, he puts a little arrow, and then it says third magnitude guide star, Delta Geminorum, and then a CWT. So that is pretty cool. And again, he's made little arrows and little underlines, right? So he's like annotating my book. So, he spent a substantial amount of time, sort of going through this and marking things. Now, I don't think that there's anything else. I don't think that there's anything else. As far as I know, there are no other markings in this book. Because, of course, I read the book after I got it, and the markings were already there. So, okay, that's him in 1978. Anyway, so yeah, it's pretty awesome. I've got 2 signatures and a and an initial. So yeah, it's just very, very cool. It's yeah, very, very fun. So yeah, pretty excited about New Horizons flying by that next object. That's going to be happening at the end of this year, the last day of the year. New Horizons is going to be flying by a Kuiper Belt object. I think something like 2 billion miles, 2 billion kilometers. Not sure. Past the orbit of Pluto. So way, way, way out there. They're going to be flying by some kind of an object. What I think it was it Grinspoon? Yeah, Grinspoon was saying that it looks like either a double lobed or maybe um, a binary object. So it seems very, very strange to me that there are so many of these lobed objects out in out in space. These double-lobed objects. I wonder if there's, I don't know. I wonder if there's something going on there that we're not understanding. So, astronomers always want to blame it on, collisions. And it's like, there are other processes, maybe, other than things smashing into one another, um, that could cause that. Yeah, I don't know. I don't know. Cheers. So, yeah, that's very, very cool. And the other day when I was, I think the last time I was outside, I was talking about, this idea of what a planet is and all of that, and I I I am looking forward to our definitions of things changing. That's how it should be, right? Things, well, not only should they be that way, they are that way. Things change. And in fact, even change changes. So uh, I mean, if we're not happy with the definition of a planet as it's defined now, sort of in an official way, and there's a good argument for the idea that should, well, a good question to consider, and that is, should astronomers be deciding what a planet is, right? Or should that be left up to the planetary scientists or the geologists, right? Somebody who knows something about uh, planets. Now, I mean, the, the for the most part, I guess I would say that the the definition, sort of the three criteria for defining a planet right now, they lean towards sort of an astronomical uh, bias, right? Um, uh, only one of the definitions talks about the object's intrinsic properties. The second, well, look, I can lay all these three out, right? The first um, way to identify a planet is that it has to be orbiting the sun, right? The second thing that defines a planet is that it basically has to be round, right? It has to have enough mass, or so the story goes, um, enough mass to compress itself into a sphere, right? So it has to be a sphere. And then the third criteria to define a planet is that it it should have sort of cleared out its orbit, so there's no other, or very, very little stuff there. And how that's defined is questionable. I mean, if it's stuff in terms of mass, um, then uh, yeah, I'm not exactly that definition. I need a probably some clarification on exactly what that means. But yeah, I mean, how it's worded, and I'm sort of paraphrasing here too. But I mean, how it's worded is that a planet will have sort of cleared its orbital path of at least largish objects, right? So, but yeah, there's uh, a lot of people are upset that Pluto was demoted to being a dwarf planet and is no longer a planet. And yeah, as I said on my live stream outside, I think that's a little, this whole thing's a little bit ridiculous because I mean, honestly, we don't really have enough data to define what a planet is. Um, and anything that we decide defines a planet is sort of arbitrary too. So I mean, it's so again, what I'm saying is let's come to some kind of an agreement, right? Which is essentially what the International Astronomical Union has done, right? They I don't think that they just sort of randomly woke up one day and said, okay, let's redefine a planet, right? I mean, there was a process, right? There was a big process, very likely hundreds, if not thousands, of minds worked on this, and came up with a definition that at least the majority could agree on. And if you want to live in a democracy, right, then the majority is supposed to rule. Right, that's how that works. So presumably a majority of the people who were considering these rules decided that these were the rules that we were going to have, or these definitions, right? Um, Parameters to define a planet, and so that's what they did. Um, yeah, I don't know if that's in the, if anything about the Bear Center is in the actual definition, right? I think afterwards there's a little bit of explanation, and maybe Berry Center is mentioned there, but those three parameters are the ones that you got to go by. So yeah. Anyway, so it's it's sort of arbitrarily chosen, and it's subject to change. So if we think that the criteria for defining a planet needs to be changed, then let's change it. That's all. It's simple. And let me tell you something too, and I will repeat this from what I said the other night. There is not, at least as far as I'm concerned, okay, there is not a hierarchy of objects, of astronomical objects, right? Where, you know, like in a solar system, right? The sun is the top thing, and then you have planets, right? And then you have dwarf planets, and then you have, moons, and then you have asteroids and comets, and down, 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 down. No, 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 no. It's all lined up like this, right? Where every single different kind of object is awesome, just absolutely awesomely fantastic, um, in its own way, in its own unique way, right? Because a planet is not a star, and an asteroid is not a planet, right? Um, that's pretty maybe self-evident. So, but having like a hierarchy is, that's a little strange. So, you know, thinking that Pluto was demoted from being a planet to being a dwarf planet, I cannot agree with that at all, because um, regardless regardless of what we think this object is, it's fantastic, right? It's amazing. It's it's like nothing that we've ever seen, right? And it's blowing people's minds because it's it it's not looking the way that it's supposed to look, right? And that's great, right? Because what that does is it's if nothing else, it's expanding those boxes that we live in, so we can change perspective a little bit, and see a little further out from where the the box is right now. That box expands a little bit, or maybe becomes a little, the walls become a little more transparent, right? So we can sort of see past our boxes. And so, as far as I'm concerned, this energy that is being expended on you know calling Pluto a planet or calling it a dwarf planet is it's it's it really seems to be like a misuse of energy and time, because isn't it just great? Isn't it great just the way it is, regardless of what you call it? I mean, I think so. So cheers to Pluto. I was I've been lucky enough to have had access to large enough telescopes to actually see Pluto with these eyes. It's it's really faint, right? It's I think around 13 and a half magnitude or so, something like that, which makes it like 7.5 magnitudes fainter than what we can see with our own eyes. So every astronomical magnitude is a factor of 2.5 times. So the difference between a first magnitude star and a second magnitude star is that the first magnitude star is 2.5 times brighter than the second magnitude star. So 7.5 magnitudes is 2.5 to the 7.5. So 2.5 exponent 7.5. And of course, I've grabbed my calculator here that every good scientist should have within arm's reach, uh, pretty much at all times. At all times. Now, I've had this calculator for many more than 20 years, probably close to 30 years. Right? It's a Casio FX 300 SA, and it's a solar powered, right? So it just goes on and on and on, right? Never never died, nothing at all. Now I wish that I would have had an HP, right? HPs are just sort of cool, nerdy things that unfortunately I never had, and I could get them now, but it's not the same. So anyway, what this says is that 7.5 magnitudes is 965 times fainter than what we can see with our naked eye. So that's pretty faint. It's almost 1,000 times fainter than what we can see with our own eyes. Um, but with a telescope, right? With a telescope with some aperture, you can actually see fainter objects, right? Much fainter. So you can see a 13th magnitude object with a 14-inch telescope, just just looking, right? If you had some way of doing like a long exposure photograph, then you could see it in a 6-inch with like a minute long exposure with a 6-inch scope. Oh yeah, yeah, you'll get Pluto, no problem at all. But if you just want to walk up to a telescope and look through the eyepiece and see it, then I'm saying that it's going to be hard with a 14-inch. You have a decent chance with a 14-inch or larger, right? I mean, if you get a 20-inch, 30-inch, 4 meter, 10 meter, you'll definitely see it. You'll definitely see it. Uh, yeah. So yeah, I've been lucky enough to be able to see that as well. And as I said, it's a challenge. It's a challenge, but it sort of um, it sort of looks like a small planetary nebula, right? It doesn't. It still does not twinkle like a star, so it's still extended enough to be able to sort of knock out the twinkling effect. Um, but yeah, it sort of looks like a very, very small planetary nebula, and it doesn't exactly pop out, but you can definitely tell that it's like that. That doesn't really look like a star. Yeah, don't know. Oh, by the way, I do have to apologize for last night's live stream. Something went weird with the computer here, and it couldn't see the internet, and so yeah, I was sort of stuck um, with it's like, okay, do I try to reboot or what, right? Because I wanted to continue for a little while, and so I tried to reboot, and that just completely destroyed everything. So thanks for hanging with me last night. Those kinds of things are going to happen, and I guarantee they will happen again. Cheers. So, but yeah, yeah, that was very, very cool. So, all right, well, I think what I want to do is I definitely want to look at some more HST images, because those look pretty cool. Those look pretty nice, pretty impressive. It's amazing, right? All of this data is freely available, right, in an astronomical data format. It's called FITS, FITS. It stands for Flexible Image Transport System, and it's just a file format. It has metadata at the beginning that sort of describes, the data type, if it's floating point, um, um, integer, um, character bytes, whatever, um, image dimensions, a bunch of other useful information, metadata, right? That's the data that describes data. Uh, and then the rest of the FITS file is just the data itself. So, if you said that this was just a big long list of um, integers between 0 and 65,535, then that's exactly what it would read the file in as, uh, and you'll be able to manipulate them, do whatever you're going to do with your image based on those numbers, right? Because that's how computers work. They operate on numbers. So, but oh, where was I going? Where was I going with that? Uh, I don't know now. I get so wrapped up in the astronomical talk that sometimes I just get flung out into the universe and get completely lost. And I look so upset about it, for sure. Cheers. HST images. Thank you, Tom. Yeah. So I'm thinking that we should probably do that, and it is extremely cool that we sitting here, right, sitting anywhere on the planet, if you have internet access, you can get access to this data, right, to the raw data, to all the calibration data, all of it you have access to. Um, you know, Data from the Hubble Space Telescope itself, right? Now, you don't have any choice in what objects are there. You don't really have any choice in how the calibrations are done, anything else. But that data is ours, right? I think there's usually like a year, 6 months to a year, where the principal investigator, the people who actually asked for the telescope time, probably paid for the telescope time, had sort of exclusive access to their data, right? And I think that lasts like 6 months or a year. Um, yeah, Uncle Bill, Big J, just maybe just don't tell me about what Big J is doing, because I have written lots and lots and lots of software to deal with Fitz headers, and they want to redo it all. So that's fine. I mean, he's going to learn a lot, right? And Big J is no dummy, right? So I mean, he'll get it. He'll get it for sure. But why they are repeating work that has been done over and over and over and over and over again, and struggling to make it work, when I'd be more than happy um, um, to work with them and get that done. The best way to deal with Fitz image headers is to use doubly linked lists. If you use doubly linked lists, where every data structure is um, is one so-called Fitz card, right? A Fitz, um, yeah, is one Fitz card. Then dealing with Fitz data is simple. Is simple. And I've done it a trillion times, right? I mean, I know how, but they just they're you know not responsive at all, and so it's like, okay, uh, you'll figure it out, you'll learn it, and that'll be cool. But it's already been done. It's already been done a lot. So yeah, it's uh, for me as a programmer, I've found that it's pretty difficult to watch somebody else write code. It's just it's too much. It's too much. I can't handle it. So yes, and Uncle Bill, let me comment on that as well. What she's talking about is IRAF. Okay, IRAF stands for the Image Reduction and Analysis Facility, and IRAF is a collection of software programs that are called tasks that allow astronomers to do their work, right? And now this is just my opinion, right? Just my opinion, but to me, okay, grad school should be sort of like basic training, right? And most of what basic training is filtering out the crud, right? Getting rid of the people who can't handle it, right? You're thinning them out, right? You start with this big huge crowd, right? That want to be want to be in the army, right? Want to be an astronomer, right? And my understanding is that graduate school is a way of thinning that out, getting rid of those who can't hack it, right? Astronomy and science and life in general is not for everyone. Okay, we are not here to to allow everyone to do everything, right? That's no fun, right? Some people do this, some people do that, and if somebody wants to change, and they were doing this, and um, um, now they do that, that's fine, no problem at all. But to say that everyone who wants to be an astronomer should be, let's ram it down their throats, let's ram it down everybody's throat and say, if you want to be an astronomer, you're going to be an astronomer, right? Now, to me, okay, being a graduate student in astronomy means that you will encounter IRAF, okay? And if for any reason that IRAF makes astronomy grad students cry, then in my humble opinion, out they go. Out. Throw them out, okay? Because I want smart, attentive, intelligent, um, strong-minded students. Okay, I I am not going to hold a 22, 23-year-old person's hand while they're crying over IRAF because it's too hard. It's too hard to figure out. It's too complicated. There's too many parameters. There's too many this, too many that. It's too hard. No, if it's too hard, get out of the way. Just get out of the way. Okay? Go cry somewhere else, right? Do your own thing. So that's just my attitude about that. I'm I'm not of the school of thought that everybody should be coddled and handheld, right? I think that if you want to be an astronomer, right, then you will do that any way that you can, right? Any way that you can. And if you need to figure something out, you figure it out. And that's it. You don't sit around crying, right? Waiting for somebody to help you or anything else, right? You get out of everybody's way and figure it out yourself, right? And that is the way to do it, right? That's the way to be a professional, right? To be a professional, um, you have to earn that, right? You have to earn that. And that does not mean regurgitating facts, and it doesn't mean having your hand held in any means whatsoever. And let me tell you something. Let me tell you something. Big J and Pamela and everybody else is going to do all this work, and what they're going to come up with is something probably as complicated as IRAF, because IRAF and other pieces of software like it are, I mean, what we're trying to do with astronomical data is very complicated. It's very hard, okay? There's nothing simple about it whatsoever. Nothing, nothing, zero. It is hard. It's really hard. And so the software that we use to process the data, to reduce the data, to calibrate it, um, all of that is extremely complicated. All of it is. All of it is. There is no way that I know of, and more power to them if they can do this, right? But I mean, I've been in this business my entire adult life, right? 30 years. 30 years. Um, and there's no way to uh, really make things any simpler than what they are. Um, and so I'm sorry, but if IRAF makes astronomy grad students cry, then they should get out. Just get out, okay? And allow those who can do that work to proceed, right? Don't be a drag, right? And that's what these crybabies are, right? They're drags. So just get them out of the way, and you know, maybe they need to work at their own pace. Maybe they need to write their own software to realize that it's like, huh, well, that's exactly what IRAF is doing. So, and IRAF is open source. Um, most people don't know that, right? That it's completely open source. It has been since the beginning. It always will be. And you can write your own tasks. Um, there's even an IRAF programming language, right? It's sort of a hybrid between Fortran and C, but you have access to all the IRAF libraries as well, and there are thousands of them, and yeah, I mean it's extremely powerful, and I'm I yeah I guess I just have no sympathy uh, if IRAF makes people cry because um, you know I was using and programming IRAF when I was 20 years old, and it it is definitely complicated. It's really complicated, right? You have to want it, I guess. You have to want it, and if you can't do it, well then you know either figure out another way, right, or get out of the way. So just my humble opinion, and I'm almost out of hydrogen hydroxide. So hopefully that project that Big J is doing and Pamela is a success. But yeah, you know, one, I've sort of determined that I just cannot watch people write code because it just it's I know too much, I guess, and it just yeah, it's not educational or entertaining to me at all. So, yeah. All right. I think with that rant, I'm going to get out of here for today. Um, yeah, I think that's it. I think that's it. So, well, have a great evening, a great day tomorrow. We'll definitely be back. Same time, same place, 2 hours UTC, right here on this channel. If you haven't subscribed yet, make sure to. You can hit the notifications. You can hit the thumbs up or the thumbs down, whichever you prefer. Um, you can make some comments. I like to see comments. I know Tim Robinson has been making some comments, and I watched some of his live stream uh, after the fact um, today as well. And yeah, Tim's pretty cool. Um, and yeah, so make sure to subscribe, share this around, right? I mean, I'm trying to find our core our core group, those who are sort of going to be here uh, regularly, and you know share a common interest, a common passion um, for the science of astronomy, right? There's always some awesome things going on. One last thing, if you haven't seen it yet, the the first image from TESS, um, has come down. And I think Tom posted a link to an article about that in my Discord server. So look for that over there. Looks pretty good. Looks pretty good. You know, they chose I don't know if that was a planned image or not, but it's really busy. It's really busy. But I can see advantages for wanting, you know, to sort of test that in terms of resolution and all that. I'd like to get a little bit more information about that image, but the fact of the matter is that very soon we'll be seeing lots of images like this, and it's going to be mind blowing. It is going to be absolutely mind blowing what we're going to learn from this kind of an instrument. Not only, you know, looking for extrasolar planets, which is cool, um, but the volume of data that's going to be coming down is just mind-boggling. It's just absolutely mind-boggling. So looking forward to that, and looking forward to having access to that data, which I think is going to be available, you know, relatively soon. I don't remember what the timeline is. All right, I'm going to get out of here for now. So I will see you in a little less than 23 hours from now. So I'll see you on the spin. Okay, don't get dizzy. Hold on to your hats, and I will see you again in yeah, a little less than 23 hours. All right, take care, everybody. Bye.